Hello and welcome back to another episode of Math with Sohn. Today we are going to be doing some FSA style trig questions. So FSA stands for Florida Standards Assessment. So wherever you are in the world, that just means it's the very, very important test for geometry, and we're going to focus on the way that they would word those questions. Okay? So one of the easier ones that they could do is if they give you cosine of A is equal to the square root of 31 over 4 in triangle ABC, right triangle ABC, where C is the right angle. What is sine of angle B? Well, there is a very, very specific standard that says when you have cosine of one angle, it will equal sine of the other angle. So this is just going to be 31, square root of 31 over 4. They could word this a lot of different ways. You could have worded it as A minus 90. Other way around. We could have said sine of 90 minus A. That would still equal square root of 31 over 4. Because 90 minus A represents angle B. Okay, so we're going to deal with this topic a lot as we go through these problems. But we're also going to be solving for trig functions and just basic ones as well, because sometimes that's on the FSA. So the second one, let's say we had here right triangle with a theta, and this angle here is going to be similar to another right triangle with that angle there, an x, and a 2.8. So in this particular scenario, we actually don't have everything, but I want to figure out what is, if sine theta, that's what that angle symbol stands for, is equal to 3 over 5, what's x? And this is incorporating trig and similarity together, because we have angle-angle similarity here, which means these two triangles are identical in terms of angle measurements and therefore are proportional with some sort of scale factor. So the first thing I'm going to do is I'm going to fill in my 3 and my 5. If I go across from the theta, I get my 3 because that's the opposite, and this is the hypotenuse. And then this would be the 5 across from the right angle. With that information in tow, I can do the same thing here. I can go across from that, that's my hypotenuse. And if I go across from the theta, this is apparently the theta, I get my x. So in this case, I am going to have a problem where I'm going to have to put in x over 2.8. That would be the opposite over the hypotenuse. And that would equal opposite over hypotenuse, 3 over 5. So this is really a cross multiply type of problem. 5x would equal 3 times 2.8, which means 5x equals an ugly number. 3 times 2.8 is 8.4. And if we divide that by 5, we get x equals 1.68. All right? So, starting to get an idea of how annoying these can be. Let's do a different version of some sort of problems like this. So let's say that I have a triangle, ACB, and it's a right triangle. And we want to know, select all, apply. What is true? That's the main question. What's true? And we're going to select all, apply. FSAs love select all and apply. And there's a lot of options. So the first one is going to be A and B are supplementary. And the question to that is absolutely not. Supplementary means they add to 180. But A and B, they add to 90. So this is not true. Angles A and angle B are complementary. And that is true because complementary is 90. So that would actually work. What about if I said cos of angle A is equal to cos of angle B? And the answer to that is no. The only way that would be true is if both A and B were the same angle. So that's not going to work. However, if I said sine of angle A is equal to cos of angle B, that would work. Because if I'm focusing on angle A, my opposite and my adjacent would be here and here, but as soon as I switch focus to angle B, my opposite and my adjacent switch locations. So that's true. And the same would be said if I said sine of angle B is equal to cosine of angle A. If you switch from sine to cosine and switch the angles, your opposite adjacent switch, it's true. Tan of angle A, is that equal to tan of angle B? And the answer to that is no. Because when we switch our opposite and adjacent, the tan would flip. So it's not going to be true there. And let's do this one. What if I said sine of 90 minus A, is that equal to cosine of B? And we'll do another one. Let's say sine of 90 minus A is equal to cosine of A. So one of those is right, one of them is wrong. So let's just give an arbitrary value for angle A. Let's say that was 50, which would make angle B 40. Well, how did we get that? We took 90 minus 50 to get 40. Okay? So let's do 90 minus A. A is 50. That would mean that we would have sine of 40 degrees. Is sine of 40 degrees equal to cos of B? Well, cos of B is 40 degrees. Will sine of angle of pretty much 40 degrees equal cosine of 40 degrees? Did we switch the angle? No. They're both 40. So this would not work. Nope. Not going to happen. But here, 90 minus A is 40 degrees. Is that going to equal cos of angle A? Well, cos of A is 50 degrees. We went from 40 to 50. We switched from one angle to the other. We switched from sine to cosine. That works. Okay? Let's do a few more, and then we're going to call it a day. So, let's say we have a problem that looks like this, where I have a right angle, a Y, a B, a 14, and a 34 degrees. So if we have that, and I am told to figure out what is all that is true. All right, so is tan of 56 equal to y over 14? Well, currently, we're going to focus all on the 34, all at once. So if this is 56, if I took 90 and took away the 34, that's where the 56 is coming from. It's the other angle. So I'm going to focus all my effort on the 34 for right now. And currently, 14 is the opposite, y is the adjacent, and b is the hypotenuse. So I'm not going to focus on the 56 yet. I want to focus on the 34 first. So I can focus all my efforts with these opposite and adjacents. What about tan of 34? Is that equal to y over 14? Well, let's see. 34 opposite over adjacent. Well, that's not correct. The opposite over adjacent should have meant that we had 14 over y. That's not what they wrote here. That's not it. What about if we had cosine of 34 is equal to 14 over b? Is that true? Well, cosine is adjacent over hypotenuse. Is this adjacent? 14 is not. 14 is the opposite. So this is also not true. Let's do some true ones. Let's say that we have sine of 34 is equal to 14 over b. That is true because sine is opposite over hypotenuse, and currently the 14 in relationship to the 34 is the opposite, and the hypotenuse is b. What about if I said sine of 56 is equal to y over b? Well, let's look at that. If we are now focusing our efforts on 56, if the angle switches, then I'm going to redo my opposite and my adjacent. Opposite and my adjacent would flip-flop. If the 56 was my angle of focus, my opposite would be across from that. So that's why I wanted to wait on the 56s. It'd be much easier than flipping back and forth numerous times. So now I got my 56. I'm going to do sine of 56 and the tan of 56. Sine is still opposite over hypotenuse. Is the opposite y and the hypotenuse b? Yes, that would work. And I forgot to mark the one above it. Is tan of 56 y over 14? Well, tan is opposite over adjacent. Is this the opposite and the adjacent? Yes, it is. Opposite is y, got it, and adjacent 14. They're in the correct locations. That's right. All right. So I hope this gives you a little bit of insight onto the questions that you're going to experience on the FSA. They're not always going to be typed into your calculator. I did skip over the ones that you would type in the calculator, but those are the ones you've been solving over and over again. So the ones you're solving where you just do tan times a number and you plug in the angle, that's the normal ones. These are the weird ones. These are the ones that you wouldn't use a calculator for and the ones that most people get really, really confused by. All right? That's going to do it for this episode. Till next time, see ya and stay positive. Bye.